This example comes from the previous one that started with transformations and how we look at rational functions, identify the transformations, and we said this was the fourth example that didn't make as much sense because it didn't seem to be in a form that could show transformations from our parent function, which was y equals 1 over x. It wasn't in a very user-friendly form in this case. So when we see functions like this, I've got three things that you're going to do to get it into this form. Number one, you're going to love hearing this, is long division. We're going to divide these two using long division. Now, honestly, you could do synthetic division in this case because this is a linear divisor, but we're going to do long division real quick here just to act as a refresher. When you do that long division, we'll rewrite the formula, and then finally we'll determine the transformations here. So I'm going to set this up as if it is long division. If you want to do synthetic and give that a try on your own, that's fine. You can do that. We have 3x minus 2 divided by x minus 1. As we've done before, we take a look at just the first term of each one, and we say, what do you multiply x by to get 3x? That is going to be 3. Then we multiply back down. 3 times x is 3x. 3 times negative 1 is negative 3. Remember that when we're doing long division, we subtract what's down below. So those 3x's are gone. Negative 2 minus negative 3 is really plus, so that ends up being positive 1. Now this is the remainder, and so when we're rewriting that, you express a remainder in a division problem as the remainder divided by the divisor, and in this case it's x minus 1. So here is our result when we divide these two. We've got this thing right here. That's going to be our d of x. That's just a different form for d of x. Now when we have it in that form, this is really what we're looking for. This now is something that we can transform, or at least comment on the transformations given the setup. So we've got 1 over x. This seems to indicate that it's right 1. And then the 3, we could put the 3 over here. It doesn't matter which side we could go on, but it's a positive 3, and so we're adding that to the function, so that means it is going up 3. So best way to figure out the transformations when you see a form like this is to divide and then look at the new way that the expression is written out.